Welcome to the deep dive. We've got some really interesting material today, mostly drawing from Daniel Vaughan's book, Analytical Skills for AI and Data Science. And our mission really is to pull out the key ideas on how, strong analytical skills, especially with AI and data in the mix, can help make smarter business decisions.
Yeah.
We know the goal is to get that knowledge quickly, thoroughly, but without feeling overwhelmed. So that's what we're aiming for today.
Absolutely. And I think it's crucial because there's so much hype around AI. This material helps cut through that.
Right.
The book's core idea really is that value creation comes from decisions. AI, prediction, they're powerful tools, definitely. But you need those analytical skills to actually leverage them effectively. It's foundational.
Okay, let's start there then, the evolution of AI. Because it's easy to get lost in, the sci-fi visions.
Oh, really?
But the book brings it back down to earth. It says current AI mostly is about prediction.
Deep learning, right?
Exactly. Deep learning is the engine. Think image recognition, natural language processing, like Facebook tagging photos, or when I ask my phone something.
Precisely. That's prediction in action. Powerful stuff,
But, and this is a big but the book raises, that prediction capability doesn't automatically translate into business value. Is that right?
that's a key takeaway. A lot of companies apparently have invested heavily in AI and been, well, underwhelmed with the results.
Why is that? Just predicting something isn't the whole story.
Not at all. Knowing something might happen is one thing. Figuring out what to do about it, how to turn that insight into a concrete action that solves a real business problem, that requires something more.
And that something more is these analytical skills we're talking about.
Exactly. The book argues we need a sort of new breed of analytical skills to make that translation. From the problem through the prediction to the prescriptive solution. What should we actually do?
And AI can't just automate that whole process. Not yet, anyway.
Not really, no. It still needs significant human involvement, insight, asking the right questions, which is why upskilling people is so important.
That makes sense. It also connects to those bigger debates happening, right?
Yeah.
Like the ones mentioned between Gary Marcus and Joshua Bengio.
And the book Rebooting AI touches on this too.
Yeah.
They're questioning the limits of current AI, especially deep learning, asking if it can really get to, genuine understanding or just sophisticated pattern matching.
Which underlines why human analysis is still so critical. Okay, so if prediction isn't the magic wand, how do we use analytical skills effectively? Yeah. The book gets into understanding business questions and KPIs, key performance indicators.
Yeah, and this is about shifting gears, moving past just describing what happened or even predicting what might happen towards prescribing what we should actually do.
And asking the right questions is step one.
Absolutely fundamental. How you frame the problem dictates so much. The book suggests breaking decisions down. Start with the outcome you want.
Okay.
Then work backwards. What actions, what levers can you pull? And you have to think about uncertainty and causality along the way.
I like that sequence of why questions technique. Can you unpack that a bit? It seemed really practical.
Oh, it's great. Deceptively simple. You start with an idea, like, let's launch a loyalty program.
Right.
Then you ask why. Well, to reward loyal customers. Okay, why? To encourage them to stick around longer? Good, but why? To ultimately increase our long-term revenue.
Okay, so you keep drilling down until you hit the real business objective.
Exactly. That last why gets you closer to the KPI that actually matters, not just signups, which is maybe a vanity metric.
Right, easy to measure, but maybe not impactful.
But something tied to the bottom line, like long-term revenue or customer lifetime value, it forces clarity.
So for that marketing campaign I mentioned, the why isn't just clicks. Maybe it's qualified leads or actual sales influenced by it.
Precisely. You need that clear line of sight. And the book also cautions about relying only on what customers say, right? Like with loyalty metrics.
Yeah, that was interesting. Surveys like Net Promoter Score are useful, but
But you need to see if their behavior matches their words. Are they actually buying more, staying longer, or just saying nice things on a survey? Look at the actions.
okay, that leads nicely into the anatomy of a decision framework the book lays out.
That visual really helped me.
It's a useful structure. You've got your objective measured by those core KPIs. You achieve those through actions or levers you can pull. Those actions have consequences, but those consequences are also shaped by the environment, things outside your direct control.
Market shifts, competitor moves.
Exactly. And the warning is about fruitless decisions, acting without a clear objective tied to a real KPI, just pulling levers randomly, hoping something good happens.
Wastes time and resources. Got it. Okay, now things get a bit more complex. Causation, correlation, uncertainty. This is where data can get tricky.
Super tricky. The book hammers home the correlation versus causation trap. It's so easy to fall into.
That example was wild CO2 emissions, UK divorces, and Mexican GDP all going up together. Yeah, a classic spurious correlation. They were all just increasing over the same time period. There's no causal link, just a shared time trend.
It's a powerful reminder. Just because two lines on a graph move together doesn't mean one causes the other.
Absolutely critical. And that brings in confounders.
Right, those hidden third variables, that might be the real cause behind the correlation we're seeing.
Exactly. Maybe an improving global economy drives both GDP and CO2, for instance. Trying to identify and control for those confounders is key to getting closer to understanding actual cause and effect.
Which is essential for making good decisions. So beyond correlation issues, the book talks about 4 main sources of uncertainty. What are those again?
Okay, first is simplification. Models are simplifications of reality.
Right, all models are wrong, but some are useful. That quote.
That's the one from George Box. And Einstein's as simple as possible, but not simpler. Because we have to simplify, we introduce uncertainty.
Makes sense. What's next?
Heterogeneity. People are different. Customers, employees, they don't all react the same way. Their preferences vary, their situations vary. That variation is a source of uncertainty.
Okay, simplification, heterogeneity.
Then, complex and strategic behavior. People react to systems. Customers might game your loyalty program. Sales teams might adapt to commission structures in ways you didn't anticipate.
Strategic behavior and complex behavior even without strategy.
Yeah, like Conway's Game of Life example.
Yeah.
Simple rules can lead to incredibly complex, unpredictable, emergent patterns. No strategy involved, just complexity arising from interaction.
Wow. Okay, and the last one.
Pure ignorance. Sometimes there are just things we don't know, fundamental unknowns about the situation.
Okay, simplification, heterogeneity, complex strategic behavior, and ignorance. That covers a lot. And the book touches on probability distributions, too. Like, not everything is a coin flip.
Right. It briefly covers things like the uniform distribution, equal chances,
Yeah.
the normal or bell curve distribution, which shows up everywhere, and power law distributions. Those are the ones with heavy tails. Think influencer followers. A tiny number have millions, most have very few. Understanding which kind of uncertainty you're dealing with matters for modeling it.
That follower example really clarifies the power law idea. Okay, so we have uncertainty, we understand where it comes from. How do we actually do something? This brings us to the levers.
Yes, the levers. These are the actions we can actually take to influence the objectives. The book splits them into 2 main types, physical and human.
Physical levers seem straightforward, like Henry Ford's assembly line or adjusting equipment based on physics technology.
Yeah, engineering, operations improvements, those are often physical levers. We understand the mechanics pretty well.
But human levers, those sound trickier.
They generally are, because they involve understanding and influencing human behavior. The book breaks down behavior drivers into preferences or values, expectations, and restrictions.
Restrictions like time and money.
Exactly. Time and money are huge constraints.
So the pricing lever is a classic human lever, right? Change the price.
But the impact isn't always simple. The law of demand usually means higher price, lower quantity demanded. But how much lower? That's elasticity.
Right. And revenue is price times quantity. So raising the price could actually lower revenue if demand drops off too much.
Precisely. It's a calculation. The book even mentions weird cases like Giffen goods where demand increases with price, but those are super rare.
And time is also a lever, not just a constraint, making things faster.
Definitely. Digital banking, one-click ordering, those 10-minute abs things, they're all leveraging our desire to save time, reducing friction.
What about levers that affect our actual preferences? That sounds powerful.
It is. The book mentions a few drivers here. Genetics, the whole nature versus nurture thing in marketing.
Yeah.
Learning what we learn individually, but also socially.
Influencers.
Influencers are a big part of social learning, yeah. Then there are social reasons, like network effects on platforms like Airbnb or Uber. Getting one side on board makes it more valuable for the other.
Right. You might subsidize riders to attract drivers, or vice versa.
Exactly. And finally, framing effects. How you present the choices matters enormously.
Ah, yeah, the TV example. Show 3 TVs, one clearly worse, one slightly better but much more expensive, to make the middle one look like the best deal.
Classic framing. Or adding a dominated alternative when selling computers. It nudges people without changing the core product. Very effective.
Okay, so we have these livers, but the world is messy. How do we model this effectively? Back to simplification.
Back to simplification and analytical muscle. Remember, Einstein and Box simplify, but usefully. We need models.
And this is where Fermi problems come in. That seemed like a cool thinking exercise.
It really is. Estimating tennis balls in a room or windows in Mexico City.
Right.
The point isn't the exact number.
It's the process, breaking it down, making reasonable assumptions, getting an order of magnitude estimate.
Exactly. It trains you to structure complex problems. And the book shows how to apply that logic to business. Valuing contact info, deciding on that startup job offer with stock options.
Right, thinking about vesting, IPO chances, discount rates.
Yeah.
It's all estimation under uncertainty.
And when modeling the effect of levers, the book stresses starting simple. Focus on the first order effect first. What's the main, most direct impact?
Don't get lost in the weeds of secondary effects immediately.
Not initially. Understand the primary driver. The book even mentions Taylor series as a way to think about first and second order effects mathematically, but the core idea is start with the biggest impact.
Okay, so we're simplifying, identifying levers, thinking about first effects. But uncertainty is still there. How do we quantify it? Expected value comes next.
Yes, expected value is key for decision-making under uncertainty. It's the probability-weighted average of all possible outcomes.
Like the coin flip gamble example. 50% chance of winning $10, 50% chance of winning nothing. Expected value is $5.
Exactly. And you can think about it from a frequentist view, what happens on average over many trials, or a Bayesian view, your subjective belief about the probabilities now.
The highway bid example showed a more complex business application, and it brought in risk attitudes.
Right. Expected value assumes risk neutrality. But most people and companies are risk-averse.
Meaning they prefer a sure thing over a gamble with the same expected payoff.
Generally, yes. That's where utility functions come in, often concave ones, to show that the value of an extra dollar decreases as you get wealthier. You care more about avoiding losses.
So the goal shifts from maximizing expected value to maximizing expected utility, which accounts for risk preference.
Precisely. Choose the lever, the action that gives the highest expected utility.
And how do we estimate those probabilities or expected values? AI, machine learning can help here.
They absolutely can. Or techniques like A/B testing.
A/B testing. Running experiments. What are the pros and cons there?
Big pro.
Yeah.
It's great for establishing causality and overcoming selection bias. You randomly assign people to different groups, A or B.
So you know the difference you see is likely due to the change you made.
Ideally, yes. Cons are, it usually gives you an average effect, not personalized. Sometimes it's expensive or just not feasible to run an experiment, and there can be ethical concerns.
Right. And the book mentions alternatives, like trying to estimate expected values directly and the whole frequentist versus Bayesian stats debate again.
And the customer churn example showed a more structured modeling approach, a microfounded discrete choice model, thinking about individual satisfaction thresholds and differences.
Okay, this feels like it's all building towards the final step, optimization.
Exactly. Optimization is the heart of the prescriptive stage. We've analyzed, we understand uncertainty. Now, how do we pick the best option?
Ranking the choices.
Ranking the choices based on our objective function, maximizing expected utility, usually. If you only have a few distinct options, you just calculate it for each and pick the highest.
Easy enough. But what if you have tons of options? Or like a continuous lever like price?
Then it gets much harder. You often rely on numerical optimization methods like gradient descent, trying to climb the hill to find the peak value.
But those can get stuck in local optima, right? Find a small hill instead of the highest mountain.
That's a real risk, yes. Optimization is complex. But, as the book notes, it's not new. Operations research, decision science. They've been optimizing inventories, routes, prices for decades.
So the tools are evolving, but the core idea isn't brand new.
Correct. And a good tip is often to start optimizing without uncertainty first, just to understand the basic mechanics of the problem, then layer the probabilities back in.
Like the capital expenditure example, allocating budget iteratively to the city with the highest expected return.
Yeah, optimizing under uncertainty means maximizing the expected value of your objective function. Customer churn interventions, cross-selling, staffing, these are all optimization problems under uncertainty.
So looking ahead, the AI-driven enterprise? What's the vision?
More data, better predictions, hopefully leading to better decisions. Maybe even machine learning models that learn the direct link from decision context to outcome, bypassing some of the intermediate modeling steps.
That sounds powerful.
Huh.
But the book ends with some important ethical notes too, right? Especially around A/B testing.
Yeah, it raises important questions. What if your B group in a test has a significantly worse experience? A confusing web page, maybe even a deliberately malfunctioning feature for testing purposes. Where's the line?
Tricky ethical ground. Defining what's morally acceptable isn't always clear-cut.
It's not. And it reinforces the need to constantly question causal claims, use experiments like A/B testing carefully to establish causality, but also be aware of their limitations, costs, and ethical dimensions.
Okay, wow, that was a comprehensive run-through.
Yeah.
So, summing up the deep dive, the big takeaways seem to be analytical thinking is absolutely vital in the age of AI. We need to go beyond just prediction to prescription.
Figuring out what to do.
Asking the right why questions to get to the right KPIs is crucial. Understanding correlation isn't causation. Getting a handle on uncertainty at sources and how to quantify it with expected utility.
And using levers effectively, simplifying complexity through modeling, and finally, optimization, finding the best path forward.
It really all ties together.
Absolutely. It's about harnessing these amazing tools, AI, data, but using our analytical minds to guide them towards creating real value through better decisions.
A great way to put it. So for everyone listening, the final thought, how do these ideas apply to decisions you're facing? Is there a lever you're pulling, maybe in your job or life, that you might rethink based on this? And what other questions pop up for you about using AI and data strategically to reach your goals? Definitely some food for thought. Thanks for joining us on this deep dive.